Okay, so for those who are on Zoom, I gave out the midterms so people can see what they got or why they got it. They could look it over. I'll also bring it next on Thursday, so in case anybody else wasn't here today, wants to see. Uh, but after that, I can't bring it every single class. Um, okay, so upload your presentation. Okay. Logic error, that's yours, Roni? Okay. So it's a PDF. Okay. You can download and better that way. A microphone, whatever you want.
Okay. Um, um,
You can download it, I think. Yeah. Better.
okay. So this presentation is going to be explaining logic errors versus runtime errors. There's three types of errors in Java: compile time, runtime, and logic. So we're going to be focusing on the last two. And the logic error is basically when you have all the syntax correct. It's just you maybe worded, incorrectly. So here, an example of a logic error is finding the average between 10 and 20. We need it to be 15, but the code, it'll divide 20 divided by 2 before, because of PEMDAS, before doing A plus B, which is what we wanted to do first. So the code will run, but it will not provide us the answer that we need of 15. It should really have the parentheses between A and B so that that's computed first, and then the that result is divided by 2. Runtime error happens while the program is running, which means everything is fine, but sometimes if I have an array and if I try to find array at index 10, but my array only has 8 elements, that might throw an error. Like right here, dividing by 0 is going to give us an arithmetic exception. So the program would compile successfully, no syntax errors, and when it runs, it would throw an error, and it would say this, exception in thread main, divide by 0, and it would stop immediately at that point. And here's a summary. So logic errors happen. The code will run successfully. It happens during the execution. It will compile fine. And the cause of it is because the reasoning is incorrect. And the runtime error compiles fine, fails at runtime, happens during the execution, and could crash the code and make it stop, and happens with illegal operations like referencing array index out of bounds or dividing by 0. Any questions?
Very good.
That's it. Thank you.
Uh, okay. Oh, what's it do? What's the runtime error again? A runtime is,
Runtime error is when we divide by 0.
oh, okay, right. And logic error is the logic. Okay, right. Okay, good. My mind goes. Uh, so now what I'd like to do is a couple of, okay, you also, okay. Uh, uh, sorry. Let's see. And upload. Just one task dependency. Right. The fun one.
Get it down. Okay, so for my presentation, it's on task dependencies in project management. So finish to start to finish to finish, and start to finish. But before I get started talking about that, we need to talk about project scheduling first because it's a big aspect of project scheduling. So project scheduling is the process of deciding how a project is broken down into smaller chunks called tasks, and when and how these tasks will be executed. So for example, in waterfall method, we break down into phases, the requirements, and then the design, development, testing, and deployment. And dependencies are a big part of the schedule's execution logic. They determine how the tasks are linked. So as I said, dependencies describe the relationship between two tasks. So they show whether one task should start after another has finished, or if it should start when another has started. They they are used for a lot of things in project management. So one, they ensure that they follow a logical and efficient order. They help project managers spot bottlenecks early. They also help in resource allocation. They prevent miscommunication and reduce the chance of blocking tasks. They improve collaboration, and they support accurate timeline planning and risk management. So managers typically use two tools to display dependencies. So there's the precedence diagramming method, and the Gantt chart. So in the precedence diagramming method, we basically just show the task as nodes with arrows pointed them to show the different dependencies. This more shows the logic of the task order, whereas with a Gantt chart, we have a timeline where the task is shown as horizontal bars, and the lines or arrows between the bars show the task dependencies. And there are four types of task dependencies, as I mentioned. There's finish to finish, start to start, and start to finish. So finish to start is, let's use task A and task B as an example. So finish to start, task B cannot start until task A is finished. Finish to finish, task B can't finish until task A is finished. Start to start, task B can't start until task has started. And start to finish, task B can't finish until task A is started. So finish to start, this is the most common type. Again, think the waterfall method. Once we can only start another stage once we finish the stage before it. It ensures a clear sequential workflow, but the main issue with this is that it causes a lot of delays because once one thing gets delayed, the whole project gets delayed. For start to start, this is where task B can only start once task A has started. So this requires a lot of close coordination between teams to prevent misalignment because it can get very confusing. But the main pro of this is that there was parallel work, so it can shorten project duration, unlike with the waterfall method where we have to wait until one phase is done to start the other. And then we have finish to finish. So this one is where task B cannot finish until task A has finished. So they can run in parallel, but their end times are linked. So this ensures that related tasks always end at the same time. But a big downside to this, as with finish to start, is that if task A lags, then task B will be delayed. And then we have start to finish. So task B cannot finish until task A has started. This is like the hardest one to kind of grasp. It's the least common, but it's mainly used for transitions. So think, say you are at work and you have to change shifts. You cannot end your shift until someone has come to start their shift. And that's all. Thank you.
Okay. So explained it very well. Yeah, thank you. Okay, okay, so now we're gonna do the, okay, I wanna try to do at least two, design patterns, maybe three. So let's start with the, let's do um, let's do the decorator pattern. I like that one. Okay, so the idea of the decorator pattern is, I'll give you an example. Does everybody know what a logger is? Anybody familiar with that? What a logger is? Um, it's basically, um, we're doing the, what's this called again? The, um, decorator pattern. Okay, so, okay, the idea over here is, so, okay, so I'm not using the typical example, because I want to make it simple. Um, so, but it's the same idea wherever it's used. So the idea of a decorated pattern is that, let's say, let's just first show an example where we don't have it and where it gets complicated. So let's say, so a logger is something like how do you debug a program? So one of the ways to debug a program is to what? You log the, as it's running, you log information, right? Right, does that make sense? Right, so that way you could see what's going on in the program, and then you could fix when things blow up. Like, for example, I once worked on a program had to do with telephone system, so we logged every single thing that happened because it kept crashing, and we didn't know why it was crashing, so we just kept track of all the different events that were happening. This line was being answered, this line was being, a call came in on this line, a call was hung up on that line, all the different things. It was a very complicated system. So we end up just we had a million lines of log. Okay. Now there's different ways to log. You could either, if you're a little bit familiar with logging, you probably heard of, um, there's, there's called, log for net or log4j. That's like a very common logging thing that people use. And it allows you to log to many different places. So without change in nodes, you basically put your log statement in the code and then use a configuration file which tells the log statement where to log. So so let's just do an example. So let's say we want to do log to file, which is probably the most common form of logging. Oh, sorry, space there. So we have log to file, and let's have it do let's do a interface, which it's going to called log. And log, I'm sorry, this interface. And log is going to have one method called log, and it's going to log a string. Okay. Log or message. Okay. Okay, everybody see this, by the way? Is it big enough? Should I turn off the lights? Yeah, can everybody see this? So log to file, for example, is going to implement the log method, and it's going to, write to a file, whatever. So logging plus message plus to file, right? So it's going to log, it's going to send it, the message to a file. Okay, then we can have, we can have another one called, we'll just do three. So let's do um, log to um, log to file, log to database, and it's also going to implement log, and I'll just copy this code over here. Um, to database. Okay, so now sometimes you want to save the logging in the database because a file is hard to get hold of, right? Because if someone's running a program on their machine, they're writing to a file on their machine, but how do you get hold of that, right? And then another common way of logging is you log to like a cloud, right? So log to cloud. So it's another way that, or to a server. So, and implements log, and um, you just put that in. It's going to log to a server. Okay, so we have three different types of logging. Now, let's say, for example, um, I I want to use, sometimes I want to use one type of logging, and then sometimes I want to use all three, sometimes I want to use one, right? So what's going to happen is I'd have to create a log um, log message, let's say object, and then I would have, let's say, I would have to have like log all. So, so I'd say public, and then public void. So I have something like this where I have to create a log to database, and then come on, equals to new. And then I'd have to pass it to message. Oh, I'm sorry. I would have to do log to database, and then I would do dot log, and then I would do message. Uh, Actually, I could just do this. And I could do um, and I could say log to file, etc., right? This will be logging for all. Um, and I can have log to server. Okay, so then let's say I only want to log to one. So then I would need another method called log um, to file. Then I would have to get rid of these um, other two. And then if I wanted to log to cloud, to log to um, uh, out to outside local machine, I would have to have, let's say, the database and the server. The point is that the point is that for all these different combinations, we have to, it gets like, there's a lot of extra code, right? Where it would be a lot nicer if we could just have one way of doing it without having to have, like, if we want to add more loggers or only have less loggers, instead of having different methods, right? We could have like just one way, one simple way of doing it. Okay, so it turns out that the decorator pattern allows us to do it. So let's do that. So let's do the, we'll call it the, well, actually, what we're going to do is we're going to change uh, the log to database. And we're going to change these a little bit, okay? So I wonder if I could do this. I could do is we could have a constructor which is going to take a um, a log object. Okay, so what we're going to do now is we're going to say that if you are a logger, you have to take actually, you know what? I haven't done this before, but it's not that complicated. All I want to do is I want to make this an abstract class. And by doing that, I could actually declare a variable in here, abstract class. And then I could declare a um, I declared a variable called previous. It would be protected, and it would be called previous. Okay, so what are we going to do? So what are we doing? So we're going to do is like this. We're doing that when you, okay, yeah, does anybody, okay, let me just explain what an abstract class is. An interface class has no code in it, right? And a concrete class is just code. A abstract class could have some code and could have just some definitions without actual code. So here, what I'm going to do is I'm going to I'm going to have a little bit of code. I'm going to have just a constructor, and the constructor is going to point to the log object that's passed in. Okay, so let's look at this again. So why is, oh, it has to be declared abstract. Okay, so now let's look. Okay, so now what we did was we changed it just a little bit. Okay, so let's say we go to log to file. So now it inherits log because log has a little bit code in it, right? And before we log to file, what's it doing? Okay, whatever. We have to use the that log, and before we and when we um, and what can happen is that before we log to file, we check to see if there's another logger before us. So for example, we could say if previous logger is not equal to null, then we would first call log, we do previous logger dot log. And we pass it the message, and then we would do our own logging. Okay, so that's all we changed. Two related problems. And then over here, we would log to database. We would do the same thing. We would do we would have to create like this. And we'd add, again, this code over here that if previous logger is not equal to null, then we could do previous logger dot log and then message. And again, where we up to file, we do the same. Oh, that is file server. We do the exact same thing. We would extend. We would do the constructor. And then we would just add this line over here, say, if there's another is not equal to null, then we're going to previous logger dot log message. Okay, so what is this code doing? Oh yeah, now let's go back to over here to our log message class, and we'll just right now I'm going to pass in null. Okay, just to get it to compile. Okay, now let's go to main. Okay, so main is where we're going to do our testing. Okay, so over here we're going to do it like this. Let's say initially let's say we want to we decide you know what, we want to log to a to a file. So we say log to file, and we say log to file. Oops. Equals to new log to file, and we have to say that there's no previous logger. Okay. So now, if we let's say we want to do log to file dot actually, we don't have to call it log to file. We could call it a log, and let's call a file or just logger. And then we could just do logger dot log, and this is our message error. Okay, so what's going on over here? So we created a log to file logger, right? We said null, meaning there's no other logger before it, and then we're going to log the an error message, right? Error in code or something, right? Line 56, okay? So if we run this now, it's only going to log to one location, right? Right, so here we go. So it did log to the file, this message, right? Now, let's say we say, you know what? What we want to do is we want to log not just to a file, we want to also log to a database. Oh, okay. So all we have to do is we have to create another logger that gets called before this logger. So over here, we just pass in a new log to database object, which has nothing in front of it. And now, when we log, we're going to run our code again. Watch what happens. So now it's going to log to the database and then to the file. See, first it logs to the database and the file. And in our code, just calls logger.log. It doesn't know how many places it's going to actually log to, right? So, and then let's say we want to log to a server, we could put that in here also. So say log to a server, and we could say there's nothing before it. So, and now if we run the same code over here, you see it's going to log to all three. It's going to log to the server, database, and file. Okay, how does this work? Well, every time we call the log method, right, what does it do? Over here, it's always going to check to see if there's another logger besides it, a previous log. If there is, then it's going to log that message. So over here, the first thing it did was we called log. So first it called the log and log to file. But log to file had a pointer to log to database. So log to database had a pointer to log to server, and then log to server didn't have a pointer anywhere. So log to server logged, then log to database logged, and then log to file logged. So that's the order it did it. So first it went into it's sort of like, you remember recursion from, like 111? So it's like it keeps on calling the one before it. Okay, but the beauty of this is that we don't have to remember, we don't have to remember, we don't care how many loggers there are, and we don't have to we don't need a messy code like this where every different time we change the loggings, right? We have to, who we log to, we have to create a new method, right? Over here, we just have one way of doing it. And if we want to change where it gets logged to, we could just get rid of it, right? We just remove the logger from there. So that's how, this is probably how code like log4net or log4j, this is probably how it works, basically. It just keeps on chaining together different loggers, and when you call one, it calls the one before it or the one after it, and et cetera, right? So each logger, so you don't have to worry about which ones are being called. All you have to do is just call the logger um, the logger object, the log object, and then whatever is in there gets called. Okay. So any questions? I know it's a little bit complicated what I just did, but you get the idea. The idea is that the idea is that we chain everything together so that automatically will call the one before it. And then I'm trying to think if I would do um, right, and also you could do it at runtime. So for example, over here, I knew ahead of time how many loggers I wanted, but for example, you could add. For example, um, I could have this. Um, I could have this, and I can only have it logged to one thing, and then um, what I could do is I could add a new logger. I could have, let's say, logger. I could pass this to, let's say, logger 3 equals to new log to database, and I could pass in logger 2. Right, so I could also do it at runtime. I could add more loggers as I go, right? I don't have to, but it's still going to be the same log, right? Um, Actually, I could do logger 2. I didn't have to do that. I could kept it logger 2. Okay, so example over here, I could at runtime add more loggers. Okay. Okay, so that's any questions? Should I go over it or um, but by the way, the decorator pattern is used a lot, like for example, with the most common example is not the one I just gave you. Most common example is a like if you have coffee and you're ordering different things to it, so then the you could just keep on adding things to the coffee without having to change the code. Okay, in other words, let's say you want to order cream and then you will order 2 sugars. You just keep on adding it to just like I did over here. See, over here I started out with only one type of logging, and then I added a new one called log to database, right? So now I have 2 loggers, right? So I could keep on adding more types of loggers, okay? So the same idea they use for coffee, like if you add cream, if you add sugar, all these different condiments, right? Then you could just keep on chaining it together. But so you don't need like a complicated list of things of what's going on. Okay. Um, like I'll just show you. You look it up. This is like the famous coffee example. Um, and this is a decorator pattern. So over here, they use uh, where's the decorator? Um, where's Head Start? Head Start. Okay, Head First, sorry. So, uh, so over here, for example, they have what they call a mocha, and then they have different types of the same idea called different things which have different descriptions, different prices, and you could add them onto your coffee, right? So you could have um, mocha, and you could add um, whipped cream. You could add 2 whipped creams, right? If they ordered more, or 2 sugars, etc. So you could keep on adding things. Right, see over here they had first they had the beverage, then they added mocha, then they added whipped cream, whatever. Okay, so and then they call get description, and then it's gonna could go through every single item, and it'll tell you the description and the price of what you ordered, right? Or it could do that. You could have it do that. So this is a more common example. I just didn't do it because I think it gets too confusing. Okay, so I did the logging way, but it's the same idea. The concept again is we're chaining different objects together so that when we call the method on one, we automatically call the same method on all the other objects that are chained together. So, and the beauty is that since they're all the same type of object, so when we call a method on one, we could, it doesn't make a difference if there's 10 of them or one of them. We just have to call the method, and whatever is there will get called. If there's 10 objects, they'll all get called. If there's one object, that's the only one they'll get called. So um, that's the idea behind it. It's a cute idea. Um, so, okay. Now okay. So the next one I want to do is going to be very simple, and it's okay. Okay. I want to do both the builder pattern and iterator, but I'll do the iterator because I think it's going to be less time. So let's do the iterator pattern and iterator pattern. So full. Okay, so why do we need the iterator pattern? So let's do a simple example and you'll see why. So let's say, for example, we have a school and inside our school, we have some teachers. Let's make a teacher object. And let's say a teacher has a name. Okay, so and in a school, let's have a array. Let's make it real simple. So in the school, we'll have when we create the school, in the constructor, let's say you have 100 teachers, okay? So we'll have an array of teachers. And that would be equal to new teacher 100, okay? And then in the constructor, we're going to do for int I equals to 0, I is less than 100, and then I plus plus, and then teacher sub I is going to be that name. I'm sorry, teacher I equals to new teacher, right? Because this over here, it doesn't actually create the objects. It just creates an array of teachers. But over here, we actually have to create each individual teacher, I'm pretty sure. And then when we do that, we also will pass in a teacher. We'll give each teacher a name. Why not? Name equals to teacher plus I. Oops, not one, I. Okay, so we'll give each teacher a name. And okay, so is anything wrong with this code? Not really, right? Okay, so what's going to be the problem with this code? So can everybody see the code on the board? You see it? Right? Yeah.
You got more than 100 teachers?
Oh, that's true also. Okay, but, okay, you're right. You're right, that is a problem, right? It should be a list, right? Or, right, okay. But yeah, there's actually a reason, yeah, okay. That's a good point. Okay, but there's, let's do a different way. Let's say, for example, I have a school over here. I create a school, right? And, and I want to print out the the names of all the teachers. So I would say for int I equals to 0, I is less than 100, I plus 1. I'm not sure you actually have to do this, but whatever. School, teacher, sub, and we'll do S out, right? Oh, name, I'm sorry. That name. Oops. Okay. Why isn't it like that? Oh, school.teacher.name. Oh, it's teachers. So it'd be school dot teachers. Isn't it teachers? Okay, so it should be teachers. Teachers. And okay, so if we run this, it should work. So let's run this. And it printed out all of our 100 teachers, right? So what's wrong with this code besides the fact that it's limited to, like you pointed out, 100, only 100 teachers, right? Let's say we have less, more, right? Well, what could be the problem, right? Well, um, the problem is that in order for Maine to print out the list of teachers, what does it have to do? It has to actually understand what's going on inside the school object, right? So the code in Maine can't just print out the list of teachers. It actually has to know the way teachers are stored within the school, which is not good, right? Because if we later on let's say we change it from an array to a list or some other way, a stack, whatever it is that some other way of storing teachers, right? Then this code is going to break. We'll have to rewrite this code, right? So that's where we come into what's known as the iterator um, pattern, the iterated design pattern. It's not used so much today anymore because um, pretty much all all objects uh, have this pretty much have the iterated pattern already used into it, so it's already actually built into them. So um, but let's just look at the idea behind the code. Does everybody understand the problem? The problem is that Maine has to, in order to print out the list of teachers, has to know too much information about the the school object, how it stores teachers, right? And we rather not be so we don't want to be so tightly coupled that when we change the school, how it stores teachers, it's going to break the code in Maine, right? All the code that looks at the teachers is all of a sudden going to break, right? So there's too much, um, um, what's the word? it's too tightly coupled. That's the word. No, they're too tight to each other so that when you change one, it's going to break the other one, right? So we don't want them to be, we want them to be loosely coupled. So even though we change one, the other one won't change. Okay, so the idea of the iterator pattern is like this, is we create a iterator. Okay, an iterator is going to be a interface, and the iterator basically has just two methods. Okay, one is a Boolean method called hasNext, and and then the other one is called next, and it returns an object. And that's all there is. And that's all we need in order to go through a list of objects. Now, in the school over here, we would create what's known as a iterator object. So we would have we'd have a teacher iterator. Listen, I would have a private class teacher iterator. And what this class is going to do is it's going to have two methods. One is going to be, it's going to implement the iterator pattern. And therefore it's going to have two methods, right? One is going to be hasNext, and one is going to be next. So, okay, so basically the teacher iterator is going to start out, basically it's going to have int I equals to 0, and and then if, and then it's if the, or let's just call it something else, count. So it's going to say if count is less than 100, right? So then, so it will return true, right? Return if count is less than 100, right? If it's less than 100, it's going to be true. Let me think for a second. That means it has a next one. And then when we want to get the next one, wait a second. Oops. Let me start at, let me think for a second. Let's start at -1, and count is going to be less than 99. No, 100. Because 99 is good. Okay. So what we're going to do is so if we want to know if there's another teacher, we're going to call hasNext. And then for next, we're going to return. Well, first we're going to increase the count by 1, right? And then we're going to return the teacher's array of count. Okay, so that's how it's going to go. So it's not that complicated. Let me just shrink this. So if you look at it now, basically all we're doing is we're basically taking the logic in main and we're putting it inside. We're basically putting inside the school object, and then over here within the school, we're going to something could say get teacher or get iterator or get teacher iterator, whatever. Get teachers and get teachers is going to return a iterator. And the iterator it's going to return is going to be the teacher iterator. So the new return new teacher iterator. Okay, so now all the logic of the teachers, how they're stored, is kept inside the school, right? And in Maine, we could change our code over here. So over here, instead of having this code, which works, but it's two coupled, right? We could have something like iterator dot iterator equals to school dot get teachers, right? And then we could have without knowing how it's stored within the school, we could say, well, iterator has next, right? We could S out, S out the iterator dot next. And then, this is a little bit of a problem because next is going to give us an object, but we have to cast it to a teacher. That's a little bit of a problem there. We probably could figure it out a better way of doing it. So we'll cast it as a teacher object, and then we're going to do the name. Okay, so this code over here just uses two common methods, has next and next, right? And so we don't have to know about 100. We don't have to know how it's stored in an array, right? All we have to do is call the has next method, and we call the next method. And this could work for any type of collection that's inside another object, okay? In fact, I did something wrong. I probably did it. What did I do? I probably, my has next. Oh, less than 100 should be count it. Oh, right, less than 99. Okay, sorry about that. And now it should work. And if we change the way it's stored, teachers are stored in the school, we just have to change the iterator that's part of the school, and we don't have to change this code over here. So this code will never change, even if we change how teachers are stored. Like, let's say we want to use a list, right? Then we just have to, or we want to use a stack, any type of database, a data structure that we use, we just, we don't have, all we have to do is just change this iterator, right? We don't have to change the code in main, right? So that's the beauty of this, okay? So we'll do at least a builder pattern on Thursday, and I'll see you, okay? And then pretty soon we'll get ready for the projects, okay? Where I'm gonna give you a pattern to do. That's why I'm doing this, so we should get a bunch of patterns for the projects. Okay? Okay, have a good night.